In set theory terms, an object is an equivalence class of different subjects having different interactions, which all fit in the same object. So in set theory, it's an equivalent relation, like an equivalence class. But that's a very stiff, Katai way of doing things. In category theory, you can have a much more elegant way to look at the interactions and the objects, how the same subject even can have a duality between interactions and objects. So we started talking about that, and at some point we'll let you know what we come up with. Well, I think these are two examples of interdisciplinary stuff, what I do for my normal day-to-day work and what I do when I really like to speculate. And I hope I've given you some sense of various aspects of interdisciplinary work. Thank you.
As a question, it depends upon your definition of the subject. But at the present stage, without combining the quantum mechanics with brain studies, we can say that the subject is just among the ingredients directly related to quantum mechanics. At present, what we can deal with only interaction and object in the present day quantum mechanics.
Yeah, I agree.
And as for Husserl, I'm very much interested in phenomenology, but unfortunately what I find is his how to say, strategy is just one direction, starting from subject to object. But to attain our genuine purpose, we have to consider the, both direction from subject to object via interaction. Not only this, but also from object to subject via interaction. And such direction is somehow, unfortunately, lacking in Husserl's ideas. That's my impression.
Yeah. As far as the first point goes about quantum mechanics, yes, I agree. What we know now is that the interaction is important. We cannot talk about an object without talking about some sort of measurement by a machine or by a person, and we don't talk about the subject. But if Galileo is one-third empirical, quantum mechanics has to be at least 2/3 empirical. Whether this is necessary or not, whether it may help. If I would make a guess, my guess is that the reason that people have so much difficulty with quantum mechanics, somebody would come up with a different way of interpreting quantum mechanics, with some sort of role for some sort of subject. It could be a robot, it could be a machine, it doesn't have to be a person, but some sort of role for this. Maybe somebody comes with a new interpretation, but it's just a guess.
In the context of quantum mechanics, could you indicate the possible way of subject being relevant to this whole?
I wish, if I knew, I would write a paper about it. I wish I knew, but I think it is important to point in possible directions, and maybe as a collaboration, maybe somebody has an idea. I mean, I say 1600 Galileo, but before Galileo, a few hundred years, people were doing all kinds of experiments and all kinds of vague ideas, and some were wrong, some were right. He didn't come out of nowhere. So we have to play with some ideas, and then maybe somebody comes up with a good idea. Maybe me, maybe you, maybe somebody else. But I think it is useful to talk about what may be missing from the current type of object-oriented science. As far as Husserl goes, what Husserl meant is not so easy to say because he wrote in old-fashioned, dry, scholarly German, which if you translate it in modern English, already it's hard to understand. And he wrote many, many thousands of pages. So, which I think is understandable because he was groping for a new idea. He was really trying to do something very, very novel. So I am trying to learn from Husserl enough that I get a sense of the direction. And then I try to think in my own way. And that is different with philosophers. Philosophers like to study Husserl and then read line by line what he wrote, and then they try to understand what did he say here, what did he say there. But physicists don't explain Newton's Principia. Physicists use Newton's ideas. So similarly, I don't care so much what Husserl saw or how much he understood. I'd like some of his inspiration, and to use that inspiration to see, can we come up with a broader way of doing science?
Any questions, comments?
Yes. So in the first part of your talk, so you mentioned that it's important to have a non-verbal or tacit level of the communication. But is it easy to have such kind of communication in Second Life, such a virtual exchange?
Well, not as well as in real life, but much more than I thought. The first time I went into a virtual world, it was not Second Life, it was a different one. I was invited to give a talk, and I had no interest in virtual worlds. It was like a video game, but a friend of mine asked me to give a talk, so I thought, sure, and I just did it. But after 20 minutes of giving a talk in virtual worlds, I felt an immersion. I felt I was in there. I felt I was part of the environment. Like if you see a movie and it's really an interesting movie, you are in the movie. You're not in your chair. You feel you're in the movie. So I was in the world with other people, and other people asked me questions, and I responded, and I was surprised how much of a sense of immersion there was. And then I tried it a little bit more, and something else which I was really surprised is that there were some people who live in Princeton who I sometimes meet in the real world, and sometimes I met in the virtual world. And sometimes when I saw them, I said, oh, last week you told me this or this. And I could not remember whether they told me in the real world or whether they told me in the virtual world. And if I have a phone conversation, I will never make mistakes. Say, a week ago you talked to me, oh no, it was a phone. I mean, I remember phone in a very different way than I remember meeting or I remember email. The fact that I could make a mistake means that if you want to say in your brain, there must be the same part of the brain using for virtual world as for the real world, because it's three-dimensional. Our whole evolution has been made to react in a three-dimensional way. A website, surfing in a website is abstract, but moving in the virtual world, you use your normal evolutionary neural system for responding. So the sense of reality, the sense of immersion and interaction is very different. And I cannot show that to you until you go in there and then you feel it. There is a very interesting statistics. If people are using virtual worlds for 4 hours, they use it for the rest of their lives. If they do it for less than 4 hours, they stop, then they don't go in. I mean, for me it took half an hour because I had a reason. They asked me to give a talk. If you don't have a reason, it doesn't take half an hour, it takes a few hours. But once you are in there, you discover that this is something not only fun, it's just, I mean, normally we have waking consciousness, we have dreaming consciousness, we have movie watching consciousness, and dreams and movies and real life are all very different. If you walk out of a movie theater, for a while the world is different, because you have to bridge the different forms of consciousness. And virtual world is yet another form of consciousness, and an interactive one that is, it has a special quality. So what we did in astronomy, I mean, I showed you the Kira Interdisciplinary Institute. We also have MICA, the Meta Institute for Computational Astrophysics, which I started 3 years ago, and we regularly have colloquium and meetings there. And instead of flying for many hours, you can just 1 hour you go in there, you have a meeting, and it is much more efficient than traveling. And some people have used MICA to write papers together, to do a collaboration and write a paper based on interaction in the virtual worlds. Very different from email.
Anything else?
Thank you.